quick one. So this is question 4. Once again, subscribe to the channel. All right. Thank you. So question 4, we have an unbalanced turbine wheel fixed to a shaft of 120 mm diameter. The total mass being 180 kg is arranged for balancing with the shaft resting on the power ways. When they step slightly from rest, oscillate with this period, which is 12 seconds, and time will be I theta dot plus mgh theta, which is equal to 0. So omega n will be equal to 2 pi square root of omega n will be equal to square root of mgh all on I, and period equals 2 pi over omega n, which will be equal to 2 pi square root of I on mgh. So from here, in the first situation or scenario, we have 12 seconds at the period, which should be equal to 2 pi square root of I. Let's double this. Let's make this one I1 all on mgh in equation 1. And another situation, have 10.5 equals 2 pi square root of I2 all on 2 times gh, equation 2. So from equation 2, we can easily get the I2, which is the moment of inertia of the whole system at the instance where a mass 2 was clamped to the system. So from here, we can say 10.5 squared before that. So 10.5 all on 2 pi is equal to, so I don't want us to write a lot, right? So 10.5 all on 2 pi squared multiplying 2 times 9.81 times 0.45 equals I2. Well, you can break it down in bits if you want, but if you divide this, you square both sides, you multiply by this, you get I2. So from there, we get I2 to be 24.656 kilogram meter square. So the balanced, in fact, I2 will be equal to the I of the balanced rotor plus ml squared, where the L is the length of the mass or the distance of the mass from the point of rotation. So we can say 24.656 minus 2 times 0.45 squared is equal to IB, which gives us 24.251 to be equal to IB. So this is the moment of inertia of the balanced rotor. Now, when we come to the question asks us to find the mass that was taken out. So we use equation 1. Now in equation 1, we have 12 equals 2 pi square root of I1 all on what? mgh. I1 will be equal to I of the balanced plus the mass added times L squared. Right? So let's make I1 a subject from the equation 1. So we have 12 on 2 pi all squared multiplying m times 9.81 times 0.45 equals I1. So 12 on 2 pi all squared multiplying 9.81 multiplying 0.45. So we have 16.102 m to be equal to I1. where I1 is equal to the, so we have 16.102 m to be equal to IB plus ML squared. So from here, IB will be equal to 16.102 m minus ML squared, where L is 0.45 squared. So M will be equal to IB all on 16.102 minus 0.45 squared, which will be equal to IB, we had 24.251. So 24.251 all over 16.10 and 0.45 squared, giving us 24.251 and 16.0.45 squared. So we have 1.53 kilogram. So the mass taken out, M, is what? 1.53 kilogram. And the moment of inertia of the balanced rotor is 24.251.